In this episode, we're going to be talking about character movement. In beat 'em up style games, character movement is slightly unique in that characters can move up and down, left and right, but the vertical is at a different speed than the horizontal speed. Some beat 'em up style games have characters jumping, and this is where some implementation might get more complex. In this episode, we'll go through steps of implementing basic movement in 4 directions, and then in the second half, adopt a version where the character can jump. In this series, we'll be using physics for movement and jumping. Be sure to like and subscribe. If you haven't watched my previous episodes in this series on beat 'em up style games, please look these up, as these videos are building off each other. We're using a new set of sprites this episode, so be sure to download them and import them into Unity. The link to the sprite sheet is in the description. Let's jump into it. I want to make one correction from the previous video. We created several sorting layers last episode of characters, enemies, and objects. We actually only need one sorting layer for any objects in the main plane area, not counting the background or the ship. If we set up more than one layer, the whole rendering order gets thrown out of whack. So please set all your characters and enemies and objects to just one layer. I'm going to move everything in my example to the characters layer and delete the rest. Let me turn on my mouse. So I want to make sure that my shredder character belongs to the characters layer, and my skelly character belongs to the characters layer, turtle belongs to the characters layer, and then my buckler also belongs to the characters layer. I'm going to go and delete the objects and enemies layer as we don't need them anymore. Go to objects, hit minus, enemies, minus. I had a layer for the guides, and this guide should now belong to characters as well. There we go. Great. If you haven't already, please download that new set of sprites. It's in the description below. In this series, I'm going to try to cover some different examples of beat 'em up style genres to cover as many bases as possible. Each episode has different examples of implementation. This episode is character movement. And while we may understand movement in other game settings, let's discuss for the beat 'em up style games. We understand that characters can move up and down, left and right. But in this genre, characters can move more quickly in the horizontal area than in the vertical area because of the way that we perceive the area in the vertical axis, in that the ship further away and the ship closer are a little bit compressed. So it perceivably should take a little bit more time to move up and down versus left and right. One other thing before we start moving on is that each character, make sure that their sprite sort point is at pivot. And this is critical for the beat 'em up style game, where we've set our pivot to the bottom of our characters, and that's where we should have that sorting point. And so for my turtle, I haven't changed this from center to pivot, and then that's why you might have noticed that when he came close to this guide, he was popping in front or behind. So now that everything's set to pivot, we can start moving forward. So again, back to movement, the horizontal is going to be a little bit faster than the other one, than the vertical. So when we start writing our script, we should have 2 separate variables for those speed values. Some other conventions that we're going to have for movement is that we're going to use physics-based movement. Of course, you can always have movement with something really simple like transform.translate, but I'm deciding to use velocity in this case. Later on this episode, we're going to implement a simple jump, and then we're going to talk about interfaces and player input. So just moving right along, let's say that we have a character that is mainly staying on the ground. This first example is about a character that does that. This turtle has some jumping sprites, so we'll come back later to talk about that. But let's say that this buckler only moves left and right, up and down, doesn't have a jump. Their main attack is going to be using this gun and this sword. So we don't we have no sprites for this character to be jumping, and we have no interest in them jumping. So we're just going to design our basic movement, character movement with this character in mind. So I'm going to select buckler, and I'm going to add a new component. So we're going to create a character movement, and it's important to sort of denote that we're doing one for a character that doesn't jump versus one that does jump. So I'm going to call this character movement. We'll hit create. This will attach the component to our buckler, and then I will open up our code editor to start implementing some code. And so we said that we want our character to be able to move horizontally and vertically. So we're going to create some private variables that are going to be private float horizontal speed, h speed. We'll maybe keep it simple, and we're just going to serialize this field so that we can see this. We're going to copy this and make a v speed here. And we said that it was essential to have two values, one for the horizontal and one for the vertical. I'm just going to start out by giving some default values. And we said that horizontal should be slightly faster than the vertical. So I'm going to set it to something like this, 10 and 6. From there, we're going to access and reference our rigid body. So we can have a serialized field. Oh no, we don't need to really have a reference to it visibly in the inspector. So we're going to call this rigid body here. Private rigid. Sometimes IntelliSense is a pain in the butt. So I just quit my code editor. I'm just going to open it back up. Rigid body, 2D, private, and we're going to call this lowercase rigid body 2D. Moving along, at some point we're going to have our character maybe be frozen because they get hit, something like that, and so we're going to have a serialized field, private Boolean variable, which is a state of either true or false. And it's going to be a can move parameter. Okay, and let's keep going. The next one is going to be, we're going to be flipping our character back and forth, and so we're going to have private bool facing right. And this gives us reference to whether our character is going to be looking to the right versus to the left. And for my character, the natural state is going to be looking to the right, so we'll set this to be true. If your character right now is looking to the left, then you can set that to be false. And then the last couple things is we're going to do a slight smoothing, and that's going to allow our character to slow down a little bit if you want to. If you don't do this, then it's not a huge deal. This is something that is sort of gives a sense of feel or touch to your character, and you might find this to be useful. So I'm just setting a basic range for my slider that's going to be present for us, and then we're going to have a serialized field of a float value, and this is going to be something that we call movement smoothing. You'll see what I mean by this in a moment. And we're just going to set a default value. One last thing is going to be something called private vector3. And this is also part of our smoothing that we're going to call this velocity. And by default, this value is just going to be zeros. Great. So now we have a reference to a rigid body. What is it? Doesn't like this. Let's just call this RB2D then. Great. At the start of this, we're going to get a reference to our rigid body so that we can, let's just call this RB2D. Great. At the start of this, we're going to get a reference to our rigid body so that we can, let's just call this RB2D. Great. At the start of this, we're going to get a reference to our rigid body so that we can, let's just call this RB2D. Great. At the start of this, we're going to get a reference to our rigid body so that we can tell it to move around. And so our RB2D reference is going to be using the get component of a rigid body 2D. Cool. From there, we don't need a start, and we don't need an update, because another class is going to call an instance of our character movement. From here, this is going to be the meat and potatoes of this script, and it's basically going to be our public void move. Not animation move. It's going to be move, and that method is going to take in our something that we call hMove, that our other script is going to use in a moment. And then we'll have a float v move, and then whether or not our character is going to be jumping or not. So these parameters are going to be used within this method. So let's see what happens. So if our character can move, then we're going to start having some logic to deal with whether our character can move or not. From here, we're going to set our velocity of our character, our target velocity. And we're going to use vector3 target velocity. And this, again, why we call it target velocity is because we're going to do some slight smoothing to our velocity so it's not herky-jerky. And we're going to be using this built-in method called smooth damp in a moment. And we're taking our vector 2 here, which is basically taking the hMove from our character input, our player input, and we're going to be multiplying it by our hSpeed. This is the value that we had declared up here. And then we're going to take our vMove and multiply that by our vSpeed. After we get this target velocity, or this is how fast we want our character to be moving, we want to smooth this out a little bit before we make our character move. And so we're going to make our character move here by setting its velocity, but prior to that, we're going to use the vector3 dot smooth damp. If you haven't looked at this before, you can always move your cursor over to the method and hit command apostrophe if you're on a Mac, and that should bring up the scripting API, and it should give you some information about what this method actually does. And what this does is basically you take a vector3 and tell it that we want to be setting this new vector3 to a certain value, and it will smooth over the transition from one vector3 to the other, and we can give it a resulting time that we want it to get there. So that's basically what it does. It really just smooths over our movement so that it is not a herky-jerky movement. And so the first parameter of this smooth damp is going to be what our current velocity is. What is our current velocity? What is our target velocity? If we want to be getting some information about the in-between that we smooth over, it updates this reference variable called velocity. And so we don't actually use this, but we need to call it within the method. And then how quickly we want to be smoothing things over. So movement smooth. In the end, what this does is it takes in some input values that we have and then sets our velocity in a smoothed out target velocity. Great. So this is basically the movement part of it. Secondarily now is that when our character starts to move, we want to make sure that our character is facing the correct direction. If we're moving this way, ultimately we want our character to look the opposite way, right? And there's plenty of methods out there. If you watched my other video, we don't want to be using our scale to flip between a negative x versus a positive x. This works, but in the end, if we have child objects within our character, it gets really, really wonky, and we don't want to do that. A better way is to take our rotation and flip that 180 degrees. And so that's the method that we're going to be doing. But before we actually do that, we need to write some logic. And so this is based on our hMove value that's basically if whether we're pressing left or right. And if we're pressing left, then the H move is going to be negative. If we're going to the right, then our H move is going to be positive. And we can use that logic to control whether our character flips or not. And so if you've done this before, then you're probably familiar with this. But the logic looks like this. We're saying if our H move value is positive, or if we're trying to make our character move to the right and we're not facing to the right, then we need to make our character flip. And so we're going to be calling this method called flip here, which we haven't written yet. It's okay. We're about to write that in a moment. Otherwise, if our H move is less than 0 and we're facing right, that means if we're moving to the left and we happen to be looking at the right, then we need to be flipping as well. So if we're facing right here, then we're going to call flip also. So we need to have these two cases described, or we won't be looking in the right direction when we move. So this is going to rotate our character, rotate if we're facing the wrong way. And we need to call this method. We're going to declare it here. It's going to be a private void flip. And within this flip, all we really do is do two things. We set our facing variable to the opposite of whatever we're facing. So when we call this flip, oops, calling it the wrong way. We do it like this. If we're facing to the right and we flip, then we need to set our facing to be false. If we're already looking to the left and we want to set the opposite, then we use this exclamation mark, which means the opposite of whatever our Boolean value is. So we change this setting here, and then we actually do the flipping in this next line. We go transform.rotate, capital R rotate, 0, 180, 0. So why do we set this 180 here? It's because we're doing it in the y-axis. If we set this to 180, you'll notice, oh, what happens to my character? They flip on the x-axis, and that's not the axis that we want to flip. We want to be flipping on the y-axis. Okay? Great. And that seems to be it. If we come back over here, then we look at our character, our buckler, we can see that there's this smoothing value, and we'll fool around with that in a moment. From here, we should set our can move to be true. So let's come over here by default, right? And so by default, we should always be able to move at the start of our scenes. And it's not until that we get hit by something, or we're slowed down, or we're taking damage, that we're going to set this can move to be false. And again, if we are not able to move, then this will be false and we'll never get into this movement factor. And so this is a good way to control whether or not your character can move at any given time. Cool, so let's go back here, and if we hit play, then we can see that our horizontal and vertical values, oh, they didn't get updated. Let's just throw these in here. Let's go 6, 10, and 6, right? And this should be true as well. That's interesting that that's not happening. That's okay. We're going to come back, but now that we have this character movement created, we're going to create a new script, and this is going to be player input. So I'm delineating what the difference between character and player are. You're the player of the game, and the thing that moves is the character. Oop, we want to create a new one, so we're going to go new script, player input, create. And what this does is it's going to take this character movement script and allow us to decide what the controls are. All right, we said that we want to use our arrow keys or WASD keys to make things happen. We'll make that all work out. And here's one way to do it. So we are going to ultimately reference this character movement script so that we can make everything move, right? So we're going to drop into our player movement, and we're going to call public, yeah, let's let's do serialized field. Let's go private. We'll do it like that. And then we're going to call the class, which is the character movement. We're going to create an instance variable for the character movement. Why don't you like this? Not really sure. We'll keep moving on. And we're going to have a couple variables that we're going to What is up with my code? Save and quit. Open you up back up. We're going to have float, horizontal movement, horizontal move, and then we're going to have another one that we're going to call float, vertical move. Great. And we need to have a reference to our character movement, and so we're going to set this variable. Oh, I'm so silly. We need to have this. This is the class that we are looking for an instance of, and the instance variable is going to be called character movement here. And so at awake, we're going to grab the instance of our character movement, which should be attached to our game object. Character movement. So we're getting the component of the character movement, which is attached to our buckler character. So this line of code is just going to have this player input get a reference to this class there. Great. And so in update, this is where we're going to be checking to see when we press our certain buttons. And we will update the values of our horizontal move from the input class. So we're saying input dot get axis. And in this case, the axis that we're looking for is horizontal. So what does this horizontal come from? Because I'm writing out this string value. Where's this? If we go to our Unity and select the edit project settings and go to input manager, there's a set of pre-made axes. Axes is plural for axis, right? And there's one called horizontal, and that already has some preset values key bound to our left and right, and also our WASD keys. So left and right arrows are bound with A and D to represent the axis horizontal. So when we press those keys, then we can get a positive and negative value in that space. We have one correspondingly with the vertical axis as well. So when we use the input class, we're saying, hey, get the information when we press left and right. If we press left, it's going to be negative. If we press right, it's going to be positive. If we press up and we're using the vertical input, then we can get those values as well. So in this case, we're doing capital V vertical. Great. And so we're taking an input here, and we have an instance variable of the character movement. And after we've pressed these values, then we're updating the horizontal and vertical move. If you remember from this class, then we have a method in here called move, which takes in a float value, which is called hmove, and then vmove, and that represents the values that we get from our input. So what we're going to do from there is we're going to, since we're using physics, we know that we're setting our velocity, our rigid body velocity. We need to update our velocity values of that character movement in fixed update. Any types of physics calculations should be done in fixed update. And so we're going to call the instance of our character movement, and we're going to use the move method and feed in our horizontal value. We can see that when we're typing in here, it's going to take some parameters: H move, V move, and jump. And so we can use the first parameter there. The next one, it says we need a float value for our V move. That's going to be, we're going to be using our vertical move there. And this last one is going to be true or false whether or not we're jumping. Since our character is not moving, is not jumping at all, we're always going to set this one to be false. But at any given time, our horizontal move could be positive or negative, and our vertical move could be positive or negative. And that's going to help our character move up or down, left and right. So let's save this. Let's jump back in here and make sure that we have our horizontal speed set here and our vertical speed here too. We're going to set our can move to default, and let's just leave this number here and we'll see what happens. If you notice in our console, it's saying that we're trying to access a rigid body that we don't have made yet. So we're going to select our buckler, and we're going to add the component rigid body 2D. And so now that we have a rigid body 2D, we can apply some physics information on it. We don't want our character to automatically fall, because if we did right now, gravity scale is set to 1, so you'll see that they just automatically fall, because now that it's being affected by gravity, by physics, it's also being affected by gravity. So we're going to move the gravity scale to be 0. And then we're going to change some of these things from collision detection to, we'll leave this off, because that's not about movement at the moment. Not so much about movement, it's more about combat in a later episode. And so we turned our gravity scale to be 0, and you notice that our character no longer is dropping to the ground. Now let's see if we can make our character move, and you can see that they are moving. You can, there's a little bit of smoothingness in that when I let up on the key, I'll press to the right and I'll let up now. You can see that they're kind of like on skates. And this is where the smoothing comes in. And this is all about feel, right? You've definitely played games where your character has some type of dampening or smoothing, and it feels like there's a bit of inertia. Or momentum, momentum to them once they start moving. And we want to try to eliminate that if that's your goal, right? We say that, oh, that feels too loose. We can move our movement smooth down to a smaller value. So if we go to the extreme, let's set it to 0, and we'll see what happens. You should find that your character moves and stops as soon as you let up. And maybe that's what you want in your game, which is great. Then you can just play around with this, and that's totally up to you, because this value will be ultimately different than mine because of the scale of your game. So let's say that we're happy with that. I'm going to let up and make sure that that's at 0, and we've effectively made our character be able to move left and right, up and down. Great. So why don't we stop there, and so that you can spend time and go back here and retrace my steps. Make sure that your character is moving up and down. The second video is going to be about making our character move with jumping. So I'll catch you guys in a moment. I need to take a short break. I'm going to start up the second video in a moment.